Hello, my name is Allan Waseka. I'm a registered architect in Uganda, and I'm currently practicing with the locally based firm.
I will be answering some of the questions you have about your building sites.
The first question is this: is it possible to adjust walls or open up the floor plan of a house without causing issues? Let's say I have my house that I have built slowly over time, and initially I had my walls done a certain way, but eventually I want it a bit more open plan. I want to be in the kitchen when I can see what's in the living room, things like that.
Well, it is possible. You can still do that. If it's still under construction, then it's still quite easy for you to do that, but I would advise that you do it with a consultant. You'd have an architect and a structural engineer to assess the integrity of the walls. That would make it easier for you to move whichever walls you want. If it's already built and there's a roof over the building or a floor, then you'd actually need to do a deeper integrity to ascertain the strength of the elements. Ideally, some walls, why you would be doing integrity would be to assess whether some walls are load-bearing or not load-bearing. Now, load-bearing walls, you'd have to take more care with them, not to remove the structural part or the load-bearing part of the wall, not remove so much of it. If it's not load-bearing, you'd be worried more about the ceilings if it's already built or the floors above. Yeah.
How can we deal with algae and dampness on exterior walls of a house? I've seen a site where this person had built and they stalled for a while. I don't know why. But then, that part where it's the plinth wall started having this green thing, the algae there. How would a person deal with that really?
Whenever you see a green lining, or what you call the green or the algae growing on the wall, is a sign of damp within the wall. It's a common problem in our environment. It's as a result of water from the ground making its way up the wall, and the problem of that, it would affect all the finishes you have on the building. In that case, you need to investigate, or again, I would advise that you consult to find out where the problem is. In some cases, it could be a result of not having a damp-proof layer or membrane between the upper wall and the foundation wall or the slab of the building. So the rising damp is actually getting from the ground and coming up. In other cases, it's as a result of splashback from a building. That would mean that the wall or the slab doesn't have sufficient distance from the ground. It's normally advised that you provide at least 150 millimeters or 200 or 300 if you can between the floor and the existing ground where you will have splashback to prevent any such issues. However, in the case where it is as a result of damp-proof, not lacking a damp-proof membrane or a cause thereof, you'd need to provide remedial methods. These, again, will depend on the extent to which you're having rising damp. In some cases, you could have to strip off the existing layer of plasterworks and redo it with waterproofing membranes. If it's a severe case where you're having a lot of rising damp, most especially if you're in a waterborne area, you'd need to look for more engineered solutions with specialist suppliers of additives that can stop the water from getting up through the wall. The problem is, if you don't deal with the source, then whichever remedial method you provide will essentially affect the finishes at a certain time.
What is your advice to someone intending to build a flat-roofed house to achieve a contemporary look? Like, those modern houses that we see. I want to do one in the village. Like, in our context, do those roofs work?
The most important thing about that question is the idea the client intends to acquire, which is a contemporary or modern style house. We want to achieve a concealed roof system, but how that can be done, there are a number of ways of achieving that. So A flat roof is one of them, but also with the flat roof, the number of flat roof types you can have. You can have a flat roof in concrete, or you could have a flat roof with a timber truss with steel metal roofing on top. So if I'm to explain a bit, a flat roof does not necessarily mean the roof is entirely flat, but it has a degree to which it's flat. So anything below 5 degrees can be considered a flat roof. So whether it will have a flat roof or not is dependent on the context. Now, in our country, we're in a tropical environment, so we receive a lot of rain in our country. So a flat roof doesn't, not to say that it cannot work, but it has to be done well to prevent any leakages affecting the internal use of the building and function of the building. If you were to have any activities up there like a terrace, then you'd recommend a concrete roof. In that case, a flat concrete roof, but that would mean you'd have to waterproof the concrete. As they're casting it, you'd have to use an additive, but as you also, after casting of the concrete and it has dried, you have to apply other methods or membranes on top of the concrete to protect it from the weather elements. However, you'd opt for other simpler methods. A roof would be one of them, or having a roof over the building. You could have a contemporary style can still have a hidden roof behind where you just put iron sheets on top and iron sheets with timber or steel, whichever on a steel structure, to house the entire facility inside. So in consultation with an engineer or a building consultant, an architect, you could get the right recommendation for such a roof system that will address all those problems and also reduce the risk of the roof leaking.
What causes cracks on buildings, and what can be done to avoid them? Is it only things for when they've just started building and the cracks come about, or is it because of how we use the building? What exactly causes the cracks on the buildings?
Cracks are an interesting phenomenon in construction. Cracks are caused by a number of things. Some are material based, some are structure based. They go to the core of the building. The cracks we are normally presented with that we often see are normally out of workmanship or material compositions of the different elements used to assemble the building. Case in point is if you're dealing with concrete, rapid drying of concrete would lead to surface cracks. That wouldn't mean that the slab of cast is not structurally sound. It only means that during the process of curing or drying, what we call it in layman's terms, the concrete rapidly dries to separate the top. And for that reason, we would normally advise that you put a PRC membrane or a mesh on top, or alternatively use fiberglass on the concrete to prevent the surface crack. So that one is material composition. Whoever is building needs to know that if you're doing concrete, you need to let it dry slowly to prevent surface cracks from appearing, which would look bad at the end of the day. Others are a result of bonding of two different elements, or two different elements having been done at different times. So if you have one wall done today and you have another wall done the next day, but if it's the same mix, same build and everything, you're bound to have a crack at that point because those two were not something continuous construction. So at that point you will have cracks. Those ones are easier to deal with because you can remedy them with finishes or use if it's in plaster, then you can use fiberglass tape around that and cast to prevent that crack from coming through the building. The other type of cracks are structural cracks. Now those are a bit more complicated to deal with because they are in the core of the building, and they're normally a sign of something failing in the building. So normally, structural crack will manifest itself as it's normally larger than the surface cracks. So while finished cracks are millimeter or 2 to 5 in depth, surface cracks are normally larger, 10 millimeters or 10 centimeter or more depth, and they're also normally deep wider. So those are a sign of something fundamentally going wrong, either the foundation failing or settling. And what in engineering terms, what we call settling is the foundation starts to sink, one sinks or one rises depending on what is happening on the ground. It will normally lead to a structure detaching from itself. In real terms, we see that in the form of cracks, or the slab being overloaded, the slab or wall being overloaded, so it actually cuts. Those structural cracks in engineering terms are never linear. They always turn up into the building. So maybe at 45 that's also a sign that that's finished cracks are normally linear, and linear in the line where possibly there's a joint or where the two materials meet. Other kinds of cracks, you have engineered cracks or what we normally term as expansion joints. Those are actually already planned for in the building. So wherever you have a large span, the structural engineers or the designers want to break the span of the building to ensure that loads are not transferred to the entire building, but also for the safety of the building, because if you have a very large building, you want to break it down into smaller chunks that you can manage it. In case there is a problem with the structure, the whole doesn't go down. So where you have expansion joints, you normally find a crack. One remedy for that is the designers can recommend that it's so hard, or you put a joint filler inside such that that crack doesn't manifest onto the finishes. However, if it does, then that can be dealt with other remedial works in consultation with engineers or architects.
Is there a maintenance-free building material for facades? Like, is there a material that I can pick and use knowing I'm not going to have to maintain this over time? Like, I do it once and I've finished with the outside part. Is it there?
There's no guarantee that there is a material that is maintenance-free. Rather, it's the frequency of maintenance that matters. Depending on the context, because as you provide the material for a building, you need to understand the context. There are some materials that we call high maintenance that require regular cleaning up and touching up for them to stay in proper condition. Others can take a beating with the weather. Now, depending on the conditions you're dealing with on the site or the building, that will inform the kind of materials. A classic example, if you deal with, if you're in an environment that is quite dusty, now there are materials that, there are materials that are not good with dust. If you're in a dusty environment or close to a road that is narrow, then you decide to have a glass facade, or you choose to have a metal facade, to definitely accumulate a little dust, and you have to be able to clean it to keep it in proper condition. However, if you went for more earthy materials, they could absorb and look more like the dust, and that it wouldn't mean you would not maintain, but the frequency of maintenance is lower than what you have for glass. It's also prudent to note that different weather conditions affect different materials. So there are some materials you cannot use in certain conditions, and if used, they would deteriorate faster than they are supposed to in the conditions in which they are designed for. So that's also an important factor. So the case in point is if you have timber, if you have a timber clad facade and it's not treated for weather, it's definitely going to start rotting when exposed to continuous rain and sun and heat. expansion and contraction will make it rot faster than it's supposed to. So in such a regard, in such a situation, you're supposed to prepare the timber for those conditions. If not prepared, then it will fail. And all goes for all other materials, even a simple item like a brick, a common item like a brick, it's going to be exposed to weather, then it needs to be prepared for the weather. So it comes down to the context in which you're using the materials for facade. If they're going to be exposed to harsh conditions, then they need to be prepared for those conditions, or they need to be engineered to survive those conditions. Even if it's a local one and it's going to be exposed to a lot of sun or a lot of rain, then it has to be coated with specific membranes to prevent it from deteriorating under those conditions. There are new additives that are being added to paint to further increase the durability of the paint. So with new paints like where you have paint consisting of UV additives, it prevents the paint from breaking down as a result of UV light. If the paint has a PVC base, it would mean that as dirt attaches itself onto a paint, then when a shower comes of rain, the dirt doesn't penetrate the paint but rather stays on the surface and can be easily washed off by rain. So you have what you call sort of a self-cleansing paint, but it doesn't mean after some time it won't need to bury it, but to mean the paint can protect the wall longer and you can have a longer lifespan of the paint without redoing the paint job again.